Hey everyone, welcome back to the channel, and today we're diving into the design of a robust hospital management system database. Whether you're a beginner in database design or looking to refine your skills, this walkthrough will help you understand how to organize data effectively in a real-world scenario. The database is designed to manage various aspects of a hospital operations. It includes tables for appointments, doctors, hospitals, nurses, patients, rooms, insurance, and medications. These tables work together to ensure smooth data flow and provide essential functionalities like tracking patient records, managing staff, and maintaining appointments. Let's start with the key tables. The Appointments table tracks appointments with fields like Appointment ID, Patient ID, Doctor ID, date, time, and hospital number. The Appointment ID is the primary key. The Doctor table stores doctor details, including the Doctor ID, first name, last name, specialization, and their relationships with nurses, supervisors, and the Doctor ID serves as the primary key. The Hospital table includes hospital information like hospital ID, hospital name, and location, and the hospital ID is the primary key. The Insurance table tracks patient information, including insurance number, patient ID, and details about the provider and coverage. The Medication stores medication details like medication ID, medication name, and dosage. The Nurses table contains nurse details, including their assigned doctors and supervisors. The Patients table, which is one of the most crucial tables, which stores patient information such as patient ID, first name, last name, diagnosis, gender, birth date, the phone number, and foreign keys to other tables like appointments, medications, and insurance. And the Rooms table links hospital rooms to patients, including fields like hospital ID, room number, entry date, exit date, and foreign keys to the nurses and patients. So, what is a primary key? A primary key is a unique identifier for each record in a table. It ensures that each row in a database table is unique, which helps in preventing duplicate records. For example, in the M appointment table, the appointment ID is the primary key, meaning no two appointments can have the same appointment ID. The primary key also serves to establish relationships between different tables. Next, let's discuss what a foreign key. A foreign key is a field in one table that links to the primary key in another table. This helps maintain relationships between tables. For an example, in the M patient table, the Doctor ID field is a foreign key that links to the Doctor ID in the M doctor table. This relationship allows us to easily find out which doctor is assigned to a patient, ensuring data consistency across the database. Now, what is a unique constraint? A unique constraint ensures that all values in a column are distinct, preventing duplicate entries. For example, in the M patient table, the phone column is defined with a unique constraint, meaning no two patients can have the same phone number. This helps maintain data integrity by making sure that each patient's phone number is unique across the entire system. Now let's discuss what the not null constraint is. A not null constraint ensures that a column cannot have a null value, meaning every record must have a value in that column. For example, in the M patient table, fields like patient ID, gender, and birth date have the not null value constraint, which means that every patient must have these values filled in. This ensures that essential data is never missing and that the database always has complete records. Drop sequence in the drop table. In any well-structured database, there are times when you need to remove a sequence or a table. Here's a quick overview of both commands. The drop sequence. This command is used to remove sequences from the database. A sequence is typically used to generate unique numbers, like when generating primary keys. When you no longer need a sequence, you can drop it to free up resources, but be cautious as dropping a sequence is irreversible. A drop table. This command is used to remove an entire table from the database, including all the data and structure. When you drop a table, all the data within it is permanently deleted, so it's important to use this command carefully. It's typically used when a table is no longer required or if you're cleaning up and restructuring your database schema. Both of these commands should be used with care in a production environment to prevent accidental data loss or disrupt your database structure. Always ensure that you have proper backups before executing such commands. Now I'm going to cut the video so we can get a closer look at the constraints and relationships of this database. Hey everyone, welcome back. We're going to get started with our constraints and relationships. So to ensure data integrity and enforce rules, we've added several constraints. The primary key, which each table has a unique identifier like the appointment ID for appointments or patient ID for patients, which is signified by the underlined name in each table. Foreign keys, which these establish relationships between tables. For an example, Doctor ID in the patient's table links to the doctor's table. A unique constraint, which is the patient's phone numbers and insurance numbers, must be unique to prevent duplicate data, and not null constraints, which is essential fields such as patient ID, gender, and birth date cannot be left empty. These constraints ensure that the database is both secure and efficient. Now let's take a deeper dive into some more of the advanced features and concepts used in the design of this hospital management system database. One important feature of the hospital management system is the ability to track hierarchical relationships. For instance, the doctors and nurses tables utilizes self-referencing foreign keys to establish supervisory relationships. The super SSN column in the doctor's table references the doctor ID of the supervising doctor, while the nurses table includes the supervisor ID field, which links to the nurse's ID of the supervisor. This design helps in managing complex staffing structures and monitoring nurses to doctor assignments. Composite keys. Another advanced feature in the database design is the use of composite keys. A composite key is a primary key that consists of more than one column. For an example, in the M room table, this combination of hospital ID and room number forms the composite primary key. This allows us to uniquely identify rooms with each hospital, preventing any duplication across multiple hospital locations. Composite key helps enforce uniqueness in cases where a single field isn't enough to ensure distinct records. Data types and optimized storage. To optimize data storage and ensure data efficiency, the database uses different data types tailored to each column. For example, the patient table uses varchar for storing data types like names and diagnosis and date for birth dates. The use of appropriate data types ensures that database can handle large volumes of information efficiently and maintain consistent access across records. Data types like date also allow for date-based operations such as filtering appointments by date, which is crucial in healthcare systems. The database design follows normalization as well principles to minimize redundancy and improve data integrity. For instance, patient details are stored in the M-patient table, while insurance information is kept separate in the M-insurance table. By organizing data in this way, we reduce the chances of anomalies like duplicate entries and ensure that changes made to a patient's insurance detail, for example, only need to be made in one place. The database design takes advantage of multi-table joins to link related data across tables. For instance, to retrieve information about a patient's doctor and their appointments, a query can join the M-patient table with the M-doctor table and the M-appointment table. Joins allow us to efficiently retrieve relevant data from multiple tables in a single query, reducing the need for redundant data storage and ensuring accurate, up-to-date information. The database is designed for scalability, and some future enhancements could include adding modules for inventory management, appointment scheduling, or detailed billing, implementing role-based access control for secure data management, and advanced reporting features to track performance metrics of staff and hospital operations. This database is a strong foundation for any hospital management system, ensuring data integrity, scalability, and operational efficiency. If you found this breakdown helpful, don't forget to like, subscribe, and let us know in the comments how you'd improve this system. See you in the next video.